Hi Jess, this is your professor Megan Bunnell, and I wanted to send you a quick video on how to solve this problem just because there are multiple steps, so I thought it would be easier for you to understand if I just walked you through the problem. So here we're asked to add two rational expressions. We have 18 over x squared plus 6x plus 9 plus 6 over x plus 3. Whenever we add rational expressions, we have to make sure that the denominators are the same. So right now we have x squared plus 6x plus 9 as one denominator, and then the other denominator is x plus 3. So you can see that these two denominators are different. We need to rewrite each fraction so that they have the same denominator in order to add these two expressions together. The first step when we have different denominators is to look at each denominator and factor it. So we'll take the first denominator, which is x squared plus 6x plus 9, and we're going to factor it into two sets of binomials. So this is just the reverse of the FOIL method. The first step in factoring is to look at the first term, so we have x squared, and we ask ourselves what times what gives me x squared? Well, x times x is x squared. So that means that I can place an x in the first position of the first parenthesis, and I can place an x in the first position of the second parenthesis. Next, I'm going to look at the last term, and I have a positive 9. So I'll write the factors of 9. So I have 1 times 9 and then 3 times 3. I need to choose the set of factors that when added or subtracted together give me a 6. So if I add 3 plus 3 together, I get 6. So I'm going to choose that pair of factors. Now I need to decide the signs to place in the parentheses. If we look at our original problem, we have a plus and a plus. So that means when I multiply these two together, I need to have a plus 9. And when I add them together, I need to have a plus 6. So that means that I will have a plus sign in each parenthesis. And you can test this out real quick by doing positive 3 times positive 3, and that will give me a positive 9. And then you can do x times positive 3, which is a positive 3x, and then add it to the inner, which is a positive 3 times x, which is a positive 3x, and we do get a positive 6x. So that means that my factors are correct. Now you can also take those factors x plus 3 times x plus 3 and just do the FOIL method, which is first, outer, inner, last, to see if you come up with the original expression. And if we do the FOIL on these two, we will get x squared plus 6x plus 9. All right, so we factored the first denominator. So I'm going to rewrite this as 18 over x plus 3 times x plus 3. And then I have 6 over x plus 3. If I look at the second denominator, this x plus 3 cannot be factored any further. That's as far as it will go. So now that I have all of my denominators factored, I need to look at the two denominators and compare them. So how can I get these denominators to look the same? Well, I can multiply an x plus 3 to this denominator so that it will look like the first denominator. Now, if we do that, I have to do the same on top. So since I multiplied an x plus 3 on the bottom, I need to multiply an x plus 3 on top. Now I have the denominators that look exactly the same, so I can go ahead and add the fractions. So I'm just going to draw a big fraction bar, and write my denominator, which is x plus 3 times x plus 3. And then we'll add the numerators together. So I have 18 plus 6 times x plus 3. Now I'll just simplify the numerator. So I will distribute that 6. So I have 6 times x, which is 6x, and then 6 times positive 3, which is a positive 18. And again, that's over x plus 3 times x plus 3. Now I need to combine like terms on top. So I have an 18 and an 18. And when I add those together, I get 36. So my numerator is 6x plus 36 over x plus 3 times x plus 3. Now this is my answer when I add the two fractions together. This is the answer to the problem, but I need to add what x cannot equal. So here I'll just put x cannot equal, and x cannot equal any number that makes the denominator 0. So we'll take each parenthesis and set it equal to 0 and solve for x. So I have x plus 3 equals 0, and the other parenthesis is just the same, so I really don't need to do that one. So I'm going to solve for x, so I have minus 3 on both sides, so x equals negative 3. So that tells me that when x is negative 3, the denominator will go to 0, and that cannot happen because we'll have an undefined function. So my complete problem is, or my complete answer to the problem is 6x plus 36 over x plus 3 times x plus 3, where x cannot equal 3. So you'll type in this form into my math lab. Let me know if you have any questions.